Yeah, good evening, everybody. Audible? Hello.
Yes, sir, you are audible.
Okay. So let's wait for about a couple of minutes before we start our class. Okay, let's start. Yeah. Are you able to see my screen? Hello? Somebody answer?
Sir, visible.
So, so we did some functions, calculus or whatever we studied. So today in continuation of, we'll try to come up with a model. So this is what is needed when we talk about statistics. Statistics models. So how and why and all is something which we need to think about it. So if you remember your high school mathematics, probably me, you, everybody going further on learn something, especially this line of best. Somebody remember this line of best fit from your high school? Yes, anybody remembers this line of best fit? Okay, I don't know, like I'm not getting replies. I think that people have learned it. So what was taught from our high school or this thing. So one of the classes, so we had equation something like y is equal to mx plus c or something like that. Anything p, c, a or something like that doesn't matter, but the equation looks something like this. So if any, yesterday we solved something for y using solver and those kind of similar way. So we have to create a model and get an answer to this thing. That is what is important. We get this thing y is equal to mx plus c. So we were supposed to get a value for y or something like that. We solved for that y. There are equations which we tend to do it. So I'll show you in a minute. So given some value for x and we get the value. You can impute anything. So getting that y is something like this. So this is how it looks. So given y, x and all, so you create an equation. Last equation, whatever you see. So future values is predicted. Like if you input a value for any x, so you get a value for y. So this is how regression works, or conceptually or a step-by-step kind of a thing, whatever we could connect the dots, or I can connect the dot to that given something. So we solve something for y, move to the next step where we do things. So this is what is done in regression. Of course, we do it in Excel. So sometime later when we start statistics. So probably that will be the last class of thing where we'll talk about regression. But yes, so I wanted you people to have a feel that they also will do it, but in a very smaller way. So this is how we should think it. So I talked about having an equation, quadratic equation, and those kind of things and all. So having that kind of a thing, we construct the mathematical model. That is a mathematics problem that when solved will provide information about real world problem. So how exactly we do solve the problem? We have a real world problem. We create a mathematical model, we solve it, we get a mathematical solution, we interpret it. That is very much important. As seen on the diagram on my screen. This is available in the book which I have given to you. So this is how what we have to do. Why we did it or I did it to showcase like step by step why mathematics is required to understand all this and all. So please don't think anything like a black box. Nothing is a black box. You know what works behind and all. That's why knowledge was. So let's move to our class today. So I think you have this uh, manual already given to you. So let's try to put these things and get an answer to whatever is required. I need to type it out. So I type it out. Are you working along with me?
Yes, Professor.
So this is some example he has taken. So slowly he develops the concept of how do we have a data and all. So till about yesterday's class, we only did like blindly. We had some equation. So we used a solver or direct calculation. Also we did it. Today more like we are trying to build a model as such and trying to solve that thing. So the concept of linear regression is introduced here. So what exactly it means that we have some real world problem. So it's about some enrollment problem, I can say that. So how do we forecast or how do we predict something, what will happen in future, or what is the general model? So how many enrollments can happen in 2011 or something like that? Or these are some questions which we pose to ourselves. Or if you are posed this kind of question, like how do you answer that question is what is to be done here. So slowly we move to that equation, how we create that model itself, that mathematical equation we are trying to do it. So let's try to do it this way. So we'll use spreadsheet to find the regression line that models the data. So enter years. So in cells B2 and enter the enrollment data Y in cell. Select B2 to BC6 and click the scatter plot. So let's try to do that. So B2 to this thing. So I have selected this thing. Go to insert. Go to scatter plot. I have a scatter plot. So my scatter plot looks something like this. The same thing should look on your screens also. So we need to add a trend line to this. So trend is like how the enrollment will go. So a question is like how the enrollment will go in the next year. So what is the trend? We say that. So it might be cricket also. How Virat Kohli may bat or something like that. What is this, based on his past batting record? How will he bat? So somebody is a bowler. How will he bowl in the next test or something? So today you can differentiate between a test match or a one-day year or T20. God knows what all formats try to. So people do this kind of prediction kind of using this thing. Of course, they are also using all the data which is collected by the cricket statistician. He tries to predict this kind of a thing. So we also pose a problem of our enrollment here and try to do it. So I have this data. Yeah, let me try to put it. Why bother to post something? Why it's not allowing me to have this?
You have to choose whole now, A, B, C. You're choosing only year.
Yes, I have to choose everything here. So I should get the add trend line. I don't know. I'm not getting it. It is only there. I don't know.
That is next one. Actually, this line is next one. Scatter. The next one is line one. First one is like this. Scatter.
So
That. Second line is line one.
a line is there, but I want a trend line. Trend line is the line of best fit actually. So whatever is done is correct, but I don't know. The selection is not working, or I don't know. Like this is something which puts you into a lot of problems. It should not happen, but I don't know. Whenever you are really in.
It is working actually. I also tried initially. You can try another one. It will work. I did 2-3 different.
Or either it should come here. It's a format thing. Change design. It's not a design problem. It's data. Okay, and
Oh, you want to edit?
no, it's not editing actually. You just add a trend line to it. It's a way of putting this thing. That's all. I don't know. Sometimes you are in you have a it BP shoots up. Oh, thing is not working, I think so. Not sure. Okay, let me on the chart. Okay, sit formatting, select data.
The right click, the down last one, the second one, first one, right click. You choose that one, you can edit. Format line or this. Right side, yeah.
I'm able to get this one, that's all. So
Trendline.
it works actually, but not sure.
Okay.
Like
So
where
you
it
may want to click on one of those points
Yeah.
and then do a right click.
Okay.
Yes.
Yes. Good. Yeah. Get a trend line. Let me park this thing. Okay. So I have a linear thing chosen here. It's a linear trend. So as you see, it has already plotted here. So we should get a line something like this. Add trend line. So linear graph. So it will come here. So display and also check both. So display equation on chart. Equation on chart. So equation on chart is also there. And display R square value also. So this is the equation which you will get it. So line of best width. So yesterday we had an equation ready. We tried to find the value of y. Now given some historical data x and y, so we are able to get that line. Today we get these things, and whatever is the dotted line is the line of best fit. I mean to say it's an average performance line or whatever it is, we think of it in that way. So R square value is something which I'll explain later. Like for the data, it is fit better. So above 0.5 or sorry, 0.70 or something like that, if you get it, you have that R square. So regression as a whole is perfectly done, and we get the answer to this problem. So this is what is done. So we create an equation using this. That's how mathematical modeling works. You have a data, you have a response variable y, you have x's. Here only one x I have taken. In real life, you'll have x1, x2 up to xn or whatever it is. Based on that thing, you create a line. So this is the way which we try to do it. So this is a linear regression. Things are linear. Usually, you encounter these things in business or something like that. So when you move to engineering or when you move to some scientific kind of a scenario also, we tend to have other kinds of some polynomial regression or quadratic or something. Or even in business, we get this kind of other lines also, which we'll try to see here. So thanks for helping. So today a lot of programming or whatever site has discerning actually. So find out why, how, and this is how we get it. So this equation has been created. So in the class on actual linear regression, I'll show like using the drop down of that statistics data analysis, how to create regression, what are the other things we get as an output, and how do we interpret. But today, from mathematics, whatever we learn in terms of equations and all, how we do it. So this is the next logical step I wanted to show. So this is how we get it. So notice that while adding the trend line alongside from selecting linear, you could select polynomial, exponential, or logarithmic. After the regression type has selected, the Excel procedure for graphing nonlinear regression also displaying both equation R square value is the same. So that's what which we try to do. So let's move to a complex thing as I told you. So what we did was something with regard to enrollment, which is the important aspect here. So we did this enrollment here, and after we talked about it's a very basic question, however it is. So based on how we can put enrollment using this equation. So if I have this equation of y is equal to 0.7392, so put it there. Also, so I should get a value here. So let me put something. So, 0.732, and this is 13.4, 13.474. Okay. So 2011, so if my enrollment is 12, so what is the y value mean, right? So we have to, so this equation will help us solve that thing. So 0.7392 multiplied by 12 plus 13.474. So in 2011, so if my x is 12, so enrollment will be 22.44. That is how we should be able to interpret this thing. So that is why this equation is created. So that knowledge we gain from this regression. Logically, like how we, why this kind of a thing is done is clearly demonstrated. So any questions, any doubts you have with regard to this? Are you able to follow what I am trying to tell? So this is the historical thing which I have given. So this is the predicted thing.
Where exactly, sir, is this regression useful in analytics, and why do we call this a business model?
Sorry, can you please repeat it?
What is the practical, where do we practically use regression?
Yes. Very good.
And
Very good.
why we call this as a model? Why is it a model actually?
Yes. Why we call it as a model? Because to get a value of y, if I give stocks or something, so who will bet on a stock? Today, for example, you, me, and all might have a demat account. So we trade, for example. So what happens is like if you buy the services of any financial expert or something like that, he will give you good, saying that you bet on this kind of stocks and all. So what that person do, or if individually try to do it also, experience is something like based on whatever happened historically or something like that, you may have an idea or something. So that is left to Amarnath or Deva or something like that, who historically know, like, for example, how TCS stocks, how Infosys stocks. So what's the use of regression if I have to say in the context of stock listing? So if I have to buy or sell or something like that, so we also try to historically find the way, like how it will be performing in the next day or day after next or something. So at that point of time, we also try to do some kind of a mathematical modeling of the historical data, whatever we have it. So in terms of stock, if I have to say, so that is a closing price or opening price or something like that, which we'll try to put it to in our demat account. So we'll say that we'll buy the stocks at a certain amount or something like that. So why? Because you would have noted, you would have got that some 22.34 as we see on this example. So tomorrow we will go to ICICI or Geojit Securities or something like that. You will put a number there for Infosys. So what you would have done is like you would have modeled that thing. So to get that 22.34, you would have some X1 value. So what would be the X1 value? How many in the past week, how many volume of that shares would have been transacted? So what is the dollar value? What is the exchange rate of today? Or whatever it is. So these are some excess. Are they causal factors which would affect the stock price, which you would have taken and you would have got that price. So tomorrow morning, you open your Demat account, go there. So we'll pack things saying that if the stock reaches this kind of a thing, so I'm going to buy about 100 this thing, and you would have put the money in the account of this thing. So whenever it reaches 22.344, so immediately the system will buy it for you and keep it in your account. So is that right explanation which I could consider?
Yes, sir. Sir, just add on, just thinking that's why. So can we use the same equation to understand or predict how many employees may be leaving in a month?
Definitely, fantastic. Yes, why not? So what are the things you have to know? But historically, you should have some numbers. Say if it's a very large company, of say about 300 to 400 employees, if you have it like, so what is the kind of a trend which is being there? So if the company is in existence for about 10 or 15 years now, so over 15 years, so what is the trend of people leaving the company? So that would have started, say it might be not year 1, year 2 might not be thing. So year 3 onwards, people may start leaving. So each month you will have a record. So how many months? Like each year will have month is like 12 months. So about 10 means like about 120 is the data points which you will have it. So month on month, how many people live? So what are the factors? Who left? So who was in a particular age, income bracket? So which division he was working? So what is the, how many usually DUs or something? Or what was his performance rating in the last year? So these are something factors which affect the living of a person with it. So based on the thing, we'll say that. So today, February, the month ended. So you mean able to predict for March based on the historical pattern of say about 120 months. In March, so many people make the right explanation.
Sir, that cleared a lot of doubts of mine, actually. Thank you so much, sir.
Okay.
It was very helpful.
Yeah. Yes. Anybody else having any doubts with regard to this?
Sir, I am only able to add only one we have to add, or we have to add two, because to series 1, 2, 3 is there. X will choose that you cannot add for Y.
Yes. You have only one Y will be there, that's all. So
Okay.
if you put one Y, so you can have X1, X2, X3, X4 like this. So one Y. So Y is the response variable. So these are the predictors. So whatever is there, predictor 1 to 4 in. So Y is something. So for example, it's something like you are ill because of so many factors. For example, you had a fever. So what is the thing? Doctor can ask, eat outside. So whether you are exposed to some rain or something like that. So third thing is like he will only do some check like whether no, probably from winter you are going to summer. So weather change has happened. So based on that, have fever or not. It will show actually, but what are the factors which affect that? So factors is that predictors, causal things. What causes you fever? What is explained in the response variable? Does that answer your question?
Yeah, Professor, can you show the data, please? That chart data.
Which data?
The chart has a data, na? There is edit option. We'll go edit the data. Right click, edit the data.
Okay. So this one you are asked.
Yes, select data. Yeah, select data. Yeah, this is the option we can change also there. Exponent.
Yeah, we can do it. So let me put, for example, even though it's a linear thing, very linear, let me put one exponential thing to it. It won't change much because
See, at a time, forward and backward both will work.
Yes, definitely. Why not? So you have something like 14.205 to e to the power of something. We have this. So this is an exponential. So it can only create this kind of a thing. So there is mathematics. I showed one thing no, in this thing. So what is the calculations behind this thing? For a linear thing, see this much of formulas are there. Yes. How do we calculate it? Here also one y is there, one x is there. So what is the next calculation we do? X into y and x square we have to get it. So from the above table we get summation of x, summation of y, summation of xy, summation of x square. And next we do how to calculate b. The b formula is n summation of xy minus summation of x, summation of y, then divided by n summation of x square minus summation of x whole square. We put everything to this, magic happens. B is like 0.5632. Then we have this equation A is equal to y bar minus bx bar. So put y bar minus b I calculated from the above equation. X bar, x bar means the average of a column. So we get a value of 10.58. So therefore, y will be 10.58, that is the constant, plus 0.56. So all these calculations for any kind of a thing happens behind. So yesterday I mentioned something like numerical analysis is the what is inbuilt into the algorithm here. So it will do a Newton-Raphson method and calculate this thing for us. On the screen, what we will get is an equation. Does that answer your question?
Yeah, but now I see all these things. I really think it's very difficult to practice. So if I have a doubt,
Don't worry about it. So you are only doing just thing, putting everything in Excel. Excel will do it for you. You will get the equation. You should be only bothered about this equation, which I have highlighted right now. And how to calculate for the next thing is like you put these things here, put a number 12, do the calculation as I told you. B9 into B7 plus C9, you will get this answer. That's all. Job is this. So if your manager has asked for some task or something like to calculate something like how many employees leave, or you are betting on an Infosys stock for tomorrow, like what is the number? So this number is what you are interested in. So rest things Excel will take care of. How to do is what you should keep it in mind and get the answer. That should be enough.
okay, Professor, got it. Thank you.
Yeah. So this is what should be there. So why we learn this thing mathematics, come here is what this thing, because people fail to understand the gap. So that's a thing, because usually we face challenges while we come. So this class nowadays it's fine, because I'm talking about, as I told when I was in the beginning, I used to teach students from social sciences background, statistics and all. To drive the point of y is equal to a plus bx to take me about 2 months, because that was there as part of this thing. They had to pass that exam also. So it was very difficult. So why it comes? They are good. They are all MA candidates. So somebody is in MA economics, somebody is MA in political science, somebody is MA in sociology. So for their PhD degree, they have a subject statistics they have to clear, and for their thesis also they have to use statistics for data crunching. Understand, make them understand was a real difficult. So these are some challenges. That mathematics gap is the, if it is not there, it becomes challenge. It's not that I created or something like that. Theory is like that. For thousands of things, people are trying to do that. So for we see that, for example, Nirmala Sitharaman also, I mean to say, she presents a budget. So who will do it for us? There's a big statistical team which does this work for us. She only presents the numbers, what it is, and how it is there. So does anybody know that there is one official post in Government of India, and its name is known as Chief Statistical Officer. So he does, his team does it. So it's about 100 people or something like that, and who have about 20 plus 25 years of experience. And the person who gets appointed to the post is something like 35 years old. So this number crunching, this math and all the getting the numbers, I told you, that's why we learned why Excel or something. The data frame is something which we have to keep it in mind. If we get this thing right, it will be like click of a button, I can say. Nirmala Sitharaman also use something. She will not use it. She will go on presenting the numbers and so to predict what can happen, how inflation will be there, how many people will get the job, how many, how should be the railway outlay be there, how will be the defense outlay will be there, what should be given to social sector, all these things, all this number crunching and all. So behind that, it is statistics. So please remember, as an example, a live example, I can say statistics goes upon. Of course, today you have all fancy machine learning, everything coming up and all. It's all fine. Core is statistics. Behind the scenes, what works. Okay, so that was about linear regression. So this is how it looks. You can work around different option, cosmetization, like this screen, somebody has put these lines and all these things can be done. So next we'll move to a bit complex thing. In business also we can do it, but most of the times you encounter this quadratic or polynomial or those kind of things in engineering problems and what you call scientific problems mostly. But nevertheless, for example, quadratic regression, polynomial regression, so few people drive a car or a bike or something. So company which manufacture Bajaj, Tata Motors which manufactures cars and all, uses this what is known as a crash analysis. In crash analysis, things are modeled using polynomial regression or quadratic regression, those kind of things. So actually, 2 or 3 bikes are crashed actually. So they keep sensors there, they get the data. So it is simulated. So I cannot crash about 1,000 bikes and get the data. I can't do it. I'll have at the most 3 bikes are crashed. Actually, full-fledged need what you call on-road bikes are crashed. So it might be crashing against a tree, crashing against a wall, crashing against a dummy person or something like that to get data points. So there is a check. So National Institute of Road Transport is there. So it has some certain guidelines. So what's the data point which so when there is a crash and what data should be taken. So we simulate that thing. So imagine that live I have only 3 data. I'll simulate it for about 10,000 vehicles. So I can do a simulation. So that's why I told you like we use what is known as the RAND and RAND between. That's why I made it up to we simulate things. We imagine certain conditions, we simulate it. We get the data. Fitting the data, that the data will be not linear thing. So anything you go and bang against one more vehicle is not a linear problem. It is a non-linear situation. To get a non-linear thing, so you have to fit a non-linear answer. So like the way which I showed, for this linear data only, we have this thing. So it's in e power. E power and all comes with exponential. It is something non-linear. It is not a very line of best fit. It's a non-linear situation. So that's how we get those things. So you may be in any different domains, either engineering, science, business, social science. Imagine anything, wherever it, whatever process you may be working, you have to think for the and work. So that's where it helps. Where you get the data, from the data, you're about to do some post-mortem. That's what I think. Usually statistics analysis, post-mortem analysis. Historically, you have the data, come up with some ideations, going forward that these are the work. So that's how we should envision things and work. Okay. So let's move to a non-linear. So see, acreage in millions consumed by forest fires in the United States. So forest fire situation itself is non-linear. Every day will not have forest fire. Here's during this summer months in India also it happens, but we are not exposed to that much. So something's happened behind this. In India, those are also very much important. It's not reported in the media much. Of course, in India also we get forest fires and all. US and all, everything is exaggerated, and here things happen in scales. Okay, so this is a data from 1985 to 2012. So how many acres were lost in million acres? Remember, so 2.9, 1 million means 10 lakhs. So 10 lakhs means lakh means 5 zeros, 10 lakhs means 6 zeros. So 1 followed by 6 zeros into 2.9. So that much acres of land was lost in forest. So problem envisioned also is very much important. So let's try to put this in this thing and let's see what are the things to get it. Okay. Oh, my data should have. Okay. Enter values. No, he's something else. And it starts with 2.9, right? There is y. Where is the y here? I don't know. Okay, let's start putting the data at least because that also takes some time. So please work along with me. So this is here. 85, 88. Okay. See, there is a gap also. That's not linear. So after 85, 1988 only, there is some data. So I don't think I require that data. Only X is required for me. Put that thing, that should be enough, I think. Enter values 5, 8, 11. Is this data available here? Data is somewhere. Figure 47 and quadratic regression. Such I don't know, I'm not having it here. Okay, then I have to enter the data. But I don't know, he enters something like 5, 8, 11 and all. 8, 11 part of this thing. How many points? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Five, 9 is what is it? No, 5, 11. Oh, probably I see that. So it is last things is only taking 5, 8, 11. Next should be 14. I'm right. 14, 17, 20. Yeah, 17. So this what I think is the data. I don't know. So y value, I have it. Really. 2.9. So 5. 4.1. So did anybody purchase the book? The book on statistics that I told?
I purchased a physical book, sir. I got the courier today.
Okay, very good. So there are some data and so I may request, so I don't know, like just I'm telling. So there are some data because these are the data which has to be entered. So can you help me like put this data in a Excel sheet and share it to everybody? At least this thing, inferential statistics and all. Because I'm not able to copy paste. I told you this is a DRM encrypted file. I'm facing challenges. Anybody else purchased it?
Sir, the whole of the data or just those tables?
No, some couple of data, like especially whatever is there, especially in this inferential statistics chapters.
Yeah.
This is about 6, 7 and all. So especially this table 6.1
Okay.
and 6.2. Just two things there are there. So go to 7, 7.1, 7.2. So if you can put it each individually as a CSV file also, that's fine. So till about regression, whatever is there, if you can put it and share it, that would be good.
Until before that exercises, right, sir? Before the questions.
No, exercise is not required. Exercises you can put it. So only thing is like you can try it out, but only for this class I need.
Okay, sir.
So going further, if put for some classes, by the time somebody else purchases, you can also put it. Just two things, whatever 1 and 2 the author has put, that should be enough.
Sir, do you want the text also along with this table?
No. Only name it as is they have typed it there.
Okay.
So for example, group working for 3 hours, group working for 10 hours.
Yeah,
You
I'll do
have
that.
to enter it and table, mention the file name as table 6.1 or something like that and
Okay.
save
Sure.
it as a CSV file.
Okay. But 6.2 I'm not seeing, sir, actually. 6.1. Then sorry. Oh, 6.2, I got it, sir.
Here it is.
Yeah, I got
Just
that.
don't put everything, just 1 or 2 things you should be enough.
Okay.
In each chapter, 1 or 2 should be enough. Okay.
Interpretation also required, sir?
No, nothing. Just put the data and check because I'll show how to do and
Okay, I'll share this with you, sir.
because I have the initial thing. Somebody else did it for me in the last batch. I don't know, like I had it in one folder, but I don't know, something is there with me. The other things are missing. I don't know what happened and all. I'm not sure. So
That's fine, sir.
even
I will just copy this in a file and share it with you.
yeah, please do it and okay.
Sure, sir.
Thanks.
No problem, sir.
So 7.44. 9.9. 5.9, 9. So this is the data for quadratic regression. So let's B2 to C11 has been selected. So insert tab. So they have put polynomial order 2. I have to choose. Okay, let's do that. So I'll come here, go to insert tab. So when you see the data also, it looks a bit scattered. So the thing, yeah, this is the data which I get it. So that is why it becomes non-linear. Linear means something like this. So usually, if you screen my CP screen, linear data will be something somewhat similar. But when you have non-linear things, the points also is a kind of a graph comes. So this is non-linear in nature. So this is the linear thing, the non-linear structure. So business also, there was a for an EMBA class, I think this last December, I think so, batch student. So he had a live production data. So what happened is like the pandemic started, I think right from that thing, his production values, he was doing a project under me. So usually it's linear. It's a very good industry where he works and all things were linear. But the data which he had chosen for those months for the last 3 years, so it was something like 2019, 2020, 2021. So highly non-linear trend. So initial graphs which he had made showed a lot of non-linear challenges. So this project we could not use linear regression. So we did a non-linear, came up with results. So this is a in a live setting he had taken executive MBA batch student where he could do that. These are something which you will face. Just as an example, I wanted to bring it up. Okay, now graph is done. So I click on this thing, right click, add trend line. Okay, polynomial. So order is 2 already it's selected. So what are the other things which I have to get this on this display equation R square? Okay. So you notice I'm getting something like 0.0067x square, 0.0437x constant. Remember here I don't have x1, x2 and all. So it will create its own x here. So how this thing works, it is a mathematical formulation. So in nonlinear situation, it will do some kind of transformation inside. It will create a separate variable. Remember, I have provided only one x here. So this mathematics is a bit complex for this class. I may not be explained. It will be hard to convince you people also. But once you develop this understanding that how things happen in a nonlinear situation, this is what happens. And we see the R square also, it is fit okay. It's above 5. In nonlinear situation, we cannot expect the R square to be something like 0.8. This is what we do. So what I'm trying to refer is the nature of the data. I gave you an engineering problem and a live example of an executive MBA student. Last December he completed. So his previous historical data was for the last 3 years. When we started to do prediction for his data, so he had a lot of. So of course we could not resort to, because in executive MBA student use R as the language where I teach predictive analytics. So in R you could model different scenarios. And this was production data from a manufacturing industry. So I can say that it is a bit of engineering problem mixed to a management situation. That's what I can say that. So all these things you can expect. So this is the quadratic. So let me pause here for a moment. Any questions you can expect from me?
Actually, y, I am not enter this y value. Y is called 0.0067. At the timeline I did, then.
So were you able to enter the data as I have entered 5, 8, 11 and all?
Yes, yes. X and Y. Okay, yeah.
So you choose this thing, that's all. So you choose from this thing. This is the data you require. And you go to insert. Then go to this scatter plot. You'll get this scatter plot. That's all. That should be enough. So once you get this thing, as we did it, so go there, right click, add trend line. So what I have chosen is this polynomial, this thing. By default, order 2 will be there. And I have displayed the equation and the R square value. That's what I have done.
Sorry, actually, this are the timeline linear one. Then can you go?
No, linear you don't add. You add a non-linear trend. So you add polynomial. This thing is there, no? Here.
Okay.
Fourth one.
Okay.
Click on this thing. So it will create that thing polynomial. Order is 2. By default, you keep it. So why order and all? This is high-end mathematics. May not be suitable, but what to do? This is the thing which we have it. Then choose display equation on chart and display R square. You should be able to get the equation as you see on the screen.
Okay. Okay. Let me try.
So anybody else got it right? Yeah, can somebody answer?
Yes, sir.
Yeah. Okay, so this is how we get it. So this is the quadratic regression. So I'm telling you like what are the flavors which you can expect. Business circumstances also when there is change, because pandemic is something where we face some highly non-linear situation. So if somebody works in supply chain, somebody works in stock market, somebody works in other this thing and all, you might not get a linear equation. Have to resort to a non-linear equation only. So that's the best thing which I could capture live. Because in class I had only taught them linear regression. He was getting very different, got panicked and all. Because his problem statement was very good. Predicting some production, this thing like how things will go in the next quarter or something like that. But he was getting a non-linear situation. Because we started when we plotted the data, we got this kind of a non-linear data on. So live one-on-one, I have to sit with him. So we resorted to doing a lot of things. So we used a lot of R programs. So I had to really guide him on that thing. So he could not do much on his own, but that was solved. Okay, that's a live example. So you can expect this thing. That's what I am trying to. So this was what about quadratic regression. So one more thing is like we try to do an exponential regression. So this data shows the purchasing power of a dollar in recent years. The year 2000 is the base year with the Excel to exponential regression model. So purchasing power and all come in, I don't know, economics, finance or something like that. So the data, because this book actually gives examples from various domains. It is not restricted to this thing, from business, economics, life sciences and social sciences. name it, you have it here. So please have a look at this thing. There are a lot of examples there. Please try to solve it. It will be very good. Okay. In what I should enter? Okay. 0, 1 and up to 12 I have to do it. Okay. If I come to the sheet. So this is my X, my Y. Zero, 1. So 1, 0.97. Across the world, hands-on classes, various disciplines, something like the students have to enter the data and do it. So that's a practice they make it. Things are not provided as files. So that's why it is done. So that's the notion everybody adopts. Or wherever. So usually you don't, that copy pasting and all don't work. 97, 0.96, 0.94, 91, 8, 5, 3, 7, 9, 0, again 7, 9, 7, 7, 7, 5. And I go to insert. So is the we get something like over the period, dollar value purchasing power has decreased. That's what it shows. So while you write interpretation down, you have to be careful. Try to draw the way it, so it is decreasing. So actually, so these are all usually 80 to 90% are all live data. People, especially US authors and all, really take it from the situation live. Actually, pick up from actual statistics, actual data sets and try to give. Not be fictitious. So exponential, I need to do it. Right click on add trend line. Exponential is the first one. So display the equation, display the R square. So I get my answer as 0.998 multiplied by E to the power of minus 0.025 into X. So R square is 0.9787. So if somebody asks you like what will be my Y for the next 13. So how we have to do it? So 13 is what is service. So I have to put this thing. So it will be 0.9. Eight. So this will be like minus 0.025. So for this value, what I should like is equal to this value multiplied by exp exponential of bracket this one multiplied by 30 close the bracket e to the power of calculate and keep better. And also it program. That is x I have to multiply. Multiplied. Okay. First multiplying and wrong thing. Somebody help me here. I have to multiply this into 13. So this is the answer. Okay, because 0 minus 0.025 into that I have to done. Get this thing. So this multiplied by exponential can somebody help me like how to put a caret sign and I meant to say to the power of because it's not the thing. What I'm trying to do is this one, but this is not the thing. I should get 0.998 into e to the power of something. I have to do it. How to
Caret symbol will be on the numerical
No, it
keyboard.
is there, but it is not accepted. I did that thing first. So it is there. Now I have done this thing. So if I put a caret sign, it will not work, I think so. If you take it, I'm not sure. No, it is how to put it, I'm not sure. So this is
Open the
something.
bracket, sir. After exponential, open the bracket.
After exponential, open a bracket. Huh?
Okay, open the bracket there. Now put the caret symbol. Okay, now close the brackets. Enter. Okay. We type, no, that is not.
No, it is only asking the XP of a number.
I'll try this later and
Yes.
then come back to this.
Please try it. So this value is correct in terms of controls. So here I have already multiplied by minus 0.025 into 13. This value I have taken. So for the equation from the linear regression kind of a thing, I have taken this thing. This multiplied by, no, first equals this into the exponential of this number I have taken, but it is e to the power of it. So this is how it comes. So in the thing, like in the 13th year, it is showing a decrease, but that's not the way. When it should show some other number actually, if I'm right. So please try it out. So give me an answer next class. So this is how an exponential regression works. So this is the historical data which you have it. So this is the predicted one. Predicted value is this 0.72. In a sense, like from 0.75, it is decreased, but that number should be something else. Yeah, that's all. And R square is good. When I get a R square of 0.98, the regression, I mean to say the choice of exponential regression is perfect for this. That's what it is. So whatever the type of regression we have model which we have chosen, perfect. Done like this is what I had for today's class. So if you people have any questions, I'll be happy to answer. So next class will be on Wednesday, same from 7 to 8:30. We'll be talking about this.
Tomorrow, Wednesday. Is it tomorrow is Wednesday?
No, tomorrow is Tuesday, right?
Yeah, it's Wednesday.
Yeah, Wednesday.
Okay, the professor, we have to buy 4 books or we have to buy only 1 book? The last one is so mathematics, business law, that one.
Yeah, that one.
Is it showing how much they buy it cost? This
It is about 337 rupees actually.
oh, this one, data analysis, business modeling. Okay. I was checking another book you showed, na, business law, mathematics. That is the 20,000. Amazon is showing.
No, I don't buy all this. Not
Okay, this one.
No, other books, Shirobi sir. For the other book, sir has already given us the e-copy. Only this particular book, if you buy the e-book, it will cost you 337.50 paisa.
Okay.
But if you buy a physical book, it will cost you 498 rupees.
So if you see this thing, this is the thing which will come.
We have to go through a registration process and then they will.
Yes. So they will send you get registered to this thing, you buy it. So to your email ID, they will send a link actually. So when you click on the link, that will be downloaded in a folder on your laptop. Usually the default is on your download or your documents, just create a folder and there. So what you have to do is like see the difference. So this is the screen of the Adobe Digital Edition. You see this left top screen. This is how it looks. And this book will be used only by Amarnath. That's all. So that's what they want to sell the kind of thing. Or Deba or Survi, if they buy it, your link will be different from my link, and it will be tagged to your account. You cannot give it to your friend or something, it will not work.
Yeah, I was about to ask this question. Can we share and we can distribute the book? I was about to ask. Okay.
That's why
What you bought, Deba? You bought ebook or you bought hard book?
No, I bought a hard copy.
I also buy that same.
Sir, I have a problem going through these ebooks. I'm used to the previous way of looking at books. I bought one hard book.
no, ebook, yes, that's the thing. Because see, it's like last this thing also I contacted this thing because as a university faculty, so we get the thing, we contact them. They see usually good means like the sales guy of this thing is not very active. He says that no sir, if it is there on this thing, this thing I can get you. That anybody can do it, no problem. Resources are there. Usually instructor resources there. So there will be one more tab here on the screen where I'm hovering my mouse. So you get it. But he is not a very good guy. Not good guy is not active guy. So he'll say this thing and he will only ask questions. I'm going to because instructors will get lot of this thing, and I told PPTs are there, nothing is there. But that's a very good book by that professor. Only thing like hands-on, how you have to interpret it, very good book. Problem is like some publishers don't have a good sources they have created. The author might be, I don't know, like because I wrote to the author also. I don't know, I didn't get a reply from that lady, and I could not move beyond that. But the book is well written, and it's a very, I think, like for about 15 to 18 years for practice in teaching MBA students, he has come out with this. But thing is like this publisher PHA Learning is not very active. Anyway, so please go buy this and so that it will be good. So we'll have everything. So not for this thing itself, it will serve you good for other things also. Many things are there. So if you move to business analytics, have statistics, all things in basic. What can Excel do is the predictive analytics, prescriptive, descriptive, all three things are covered here. But for the predictive analytics class in EMBA, I teach using R because R is essential because we use other machine learning methods and all we taught. Okay, so I don't have any questions. So we'll meet on Wednesday 7 p.m. So the other things to cover are mostly I should be able to cover the linear equations and a bit of linear programming also is what I. Let's see how best time we have. So please be ready. Again, so we'll meet on Wednesday.
Thank you, Professor.